Real quickly, I want to talk about when vertical asymptotes occur in a rational function. Vertical asymptotes occur at the zeros of the denominator. Sometimes, but not always. Okay, so I want to kind of clear that up. Vertical asymptotes occur if there's zero in the denominator and the numerator is not equal to zero. So it has to be where you end up getting a number over zero. And if you get a number over zero when you plug in an x value, that x value will be a vertical asymptote, a number that's a non-zero number on the numerator. We'll talk about that as we teach you. If you do get 0 over 0, that's another story, and we'll talk about that later. X-intercepts occur when there is a 0 in the numerator. So if the numerator is 0, 0 divided by any number is going to equal 0. So if you have y equals f of x, a polynomial, over g of x, another polynomial, if f of x equals 0, whatever it is, then that means y is going to equal 0. And so that's an x-intercept. And an x-intercept occurs when you get some number, comma, 0 as an ordered pair. Y-intercepts occur when in this example, we're going to see a couple of vertical asymptotes. When we go to graph these rational functions, we always want to factor. The top would factor into x squared minus 2 times x squared minus 1 over x plus 2, x minus 2. You could also factor the top again into x plus 1, x minus 1 over x plus 2, x minus 2. Now, as we can see, the denominator, the first thing you always want to check is what makes the denominator 0. Well, we know that 2 does. And we know that f of 2 will equal 2 squared is 4 times 2 is 8 minus 2 is 6 over 0. That means that's called infinite discontinuity. And if you plug in a negative 2, you get the same thing. So that means we're going to have vertical asymptotes at x equals 2 and x equals negative 2. So the discontinuity, the type of discontinuity, and we do want you to know that, is infinite. And that'll be at x equals plus or minus 2. The domain is all reals. X cannot equal plus or minus 2. Vertical asymptotes will occur at x equals negative 2 and x equals positive 2. And we do want you to write that out as two separate equations of lines. You can't write plus or minus on that. It's okay to write plus or minus where there's discontinuity, and okay to say the domain plus or minus. But when you actually state the vertical asymptotes, you must state them as two separate lines. The x-intercept occurs when y is 0. And now that means, how can y 0 be equal to 0? Only if the numerator is 0. Now the numerator is 0. When we'd have it in factored form right here, it's pretty easy to see that the numerator is going to be 0 when x is negative 1 and also when x is positive 1. So when you put a negative 1 or a positive 1 in, you will get 0 in the numerator. And if the numerator is 0, then we certainly know if the numerator is 0, 0 divided by anything is 0. So y, or f of x, would be 0. So that is what happened over here. What I did there. But, gosh, I keep doing that. I don't know what I'm doing. I need to sleep. I need sleep. All right, so this is 1, 0. All right, let's get back at it. The y-intercept occurs when x is 0. So if I put a 0 in for x, the easiest place to put that into is in your original function without factored, because when you put a 0 here, the x's go away, and you get negative 2 over negative 4, which is 1/2. So that's my y-intercept. And I'm struggling here. Now, what about my end behavior? Well, my end behavior, we look at y equals 2x squared over x squared. So if I took 2x squared over x squared, we just get 2. So my end behavior is going to be y equals 2. And that is a horizontal asymptote. And that means we can plug in or put in a horizontal asymptote there. So now let's go ahead and graph this thing. Kind of a tough one right off the bat, but that's okay. We can handle it. Let's plot our intercepts, -1, 0, and 1, 0 are x-intercepts. The y-intercept is 0, 1/2, which is right there. And those are the only points we know, those 3 points. And we know we have vertical asymptotes. We have a horizontal asymptote, which tells us our end behavior. So that means if we follow our graph, we are going to be out here somewhere, but we don't know if it's above or below the curve. We know that once it gets way out there, it's not going to cross. It can cross. You can cross a horizontal asymptote in the middle, but you cannot cross it when it gets way out at the end. It's just going to hug it because it's called end behavior, not middle behavior, end behavior. So where do we put it? Easiest thing to do, just plug in a number past the vertical asymptote, and that would be like a 3. And if you plug in a 3, you're going to get 3 squared is 9 times 2 is 18, minus 2 is 16. That's positive. Down here, 3 squared is 9, minus 4 is 5. That's positive. So a positive divided by a positive is positive. That means that this graph is going to be above that asymptote and look like that. On the other end, when we plug in a -3, it's also going to be above because x is squared that you plug it into, so it's going to be the same. And then what happens in between the two asymptotes? Well, you have to go through the 3 points and hug the asymptote. And the only places it can cross the x-axis is at those points, so this has to be this way. You have no other choice. You can't go through all. Okay, here's the first problem in your homework. In case you were not sure how to do it, we'll show you how it's done. So the first thing you do is look at the domain. It's going to be all reals. X cannot be 2. We know that that will be infinite discontinuity. And that'll be at x equals 2. The vertical asymptote will be x equals 2. X-intercept occurs when y is 0, and that there will be none, because there's no way y can be 0, because the numerator can never be 0. And so now the y-intercept occurs when x is 0, and of course that will give you a -1/2. End behavior, the model is y equals 1 over x, which means we have y equals 0, because when x gets huge, that's 1 over a huge number is basically nothing or 0, and that's going to be a horizontal asymptote. So your end behavior is going to be a horizontal asymptote at y equals 0. 0, -1/2 is your y-intercept. We have a vertical asymptote at 2. And that's all we have that's all we have to go with. So what do you do now? Well, the end behavior has to be out here at y equals 0. And it's going to either come in and go up like this, or it's going to come in and go down like this. And how do we determine which one? We know it can't cross the x-axis because there are no x-intercepts. So how do you know if it's above or below? The only way you can know is to plug in a point somewhere out here. So we'll plug in a 3. And if we plug in a 3, we do get a positive value. 3 minus 2 is 1 on the bottom. And the top is, of course, always positive. So we know it's going to look like that on there. On the other side, we know that it's got to, again, be 0, but it also has to go through this point, which tells me it's going to be below. So it's going to come and go like this. And you always have to hug your asymptotes, okay, whether it's vertical or horizontal. Now, as you can see, you probably could have graphed this without doing all that by knowing it's just simply a reciprocal graph, 1 over x, shifted 2 units to the right. And, of course, that's what you see. So the second problem, a little more work to it. We'll factor the top into x plus 3, x minus 3. Divide bottom's x minus 2, x plus 3. We can see that the x plus 3's are going to cancel, which gives me x minus 3 over x minus 2. And of course, it only equals, this y equals that only if x is not equal to negative 3. Because we know that f of negative 3 will give us 0 on top and 0 on the bottom. That means we have point discontinuity, and that will be at negative 3. And what's the y value? What is the point? Well, you plug negative 3 in to the simplified. After you cancel out the x plus 3's, you plug that in for these x's right here. And when you do so, you will get negative 3. You will get negative 3 minus 3 over negative 3 minus 2, which is negative 6 over negative 5, or 6/5. So negative 3 6/5 is where the point discontinuity is. I'm going to move that down here below. And we have infinite discontinuity at x equals 2. Because when I plug a 2 in for x, on the top I'll get negative 1 times 5, which is a number, negative 10, and on the bottom you're going to get 0. And a number divided by 0 gives infinite discontinuity, and that's at x equals 2. So that means there's a vertical asymptote at x equals 2. The domain is all reals. X cannot equal 2 or negative 3. Again, at 2, we're going to have a vertical asymptote. And at negative 3, we're going to have a hole at negative 3 6/5, which is just a little bit bigger than 1. X-intercept occurs when y is 0, and the only way y can be 0 is if the numerator is 0. Now, there are two numbers that make the numerator 0. However, one of them is not in our domain. Remember, our domain cannot have negative 3 in it. Negative 3 does make the numerator 0, but it also makes the denominator 0, so that's not in the domain. But positive 3 will be an x-intercept. So we plug in that, put that point, plot it. Y-intercept occurs when x is 0, and if I plug a 0 in for x, go back to the original equation. 0 in for x gives me negative 9 on the top. And on the bottom, you'll get negative 2 times 3, which is negative 6, which is going to be 3/2. And you could get that also a little easier with that, with the simplified version there. If I should have done that, that would have been easier. So 0 3/2, that's 0 1.5. And so now, what about my end behavior? Well, the highest degree term on top is x squared. And on the bottom, if you multiply these out, you're going to also have x squared. So that's 1. So y equals x squared over x squared, or 1. So y equals 1. That means we're going to have a horizontal asymptote at y equals 1. And our end behavior is y equals 1. It's going to look just like the line y equals 1 at the end. So that means we got a pretty simple graph over here. We have to hug the end behavior. We got to go through this point. We got to hug the vertical asymptote. So that part's going to look like this. On the other side, it's got to have an end behavior of y equals 1. So it's going to go here, go through that, not through, but up to that point. And it's going to go through that point, and then it's going to curve up and hug that.